All right, welcome back. This is the second Q&A session. Thank you very much for everyone who came along and sitting in the audience. We have about 50 minutes to get through as many questions as we can. I'll just quickly introduce our speakers from this morning in no particular order, because that's the way they sat down. We have Jose Carlos Nito, Rob Pike, Renee French, yes, Katrina Owen, Bernard Schaefer, and Keith Randall. So, let's just get straight into it. Keith, do you want to kick us off with a map question?
Sure.
Yeah. You don't have your list anymore. You were keeping your own list. Okay. All right. Keith, what are good options for concurrent maps in Go, similar to Java's concurrent hash map?
That's a good question. So the Go hash maps are read safe concurrently, but they're not write safe concurrently. So you can have multiple readers and iterators on a Go map at the same time. However, if you want to write to the map, that write has to be exclusive. I don't know offhand of any good concurrent write map implementations. I'm sure there exist. People have written ones before. Again, they're hard to write outside the runtime library in a generic way, but I've seen traffic go by on Go Nuts that have maps for, int to int or something like that in a concurrent fashion. But as far as a good one, I don't know. I haven't looked at them in detail.
Okay, cool. Bernard, we have a number of questions. They're all really asking the same thing, which is, so Altman works with Xen at the moment. Can you talk about possible plans for other bare metal, other platforms?
Yeah, so Altman currently targets Xen specifically. This was chosen because it happens to run on EC2 and a number of other public clouds. It also happens to expose some special features that make it easy to get started at implementing a new thing that targets Xen. I have not looked into how this might work with KVM or other ones. I suspect that it's possible and a place that the project could grow into to support multiple hypervisors, but at the moment I'm really focused on getting the kind of core feature set working with one of them and then kind of see what the boundaries are so that it could be abstracted to multiple ones.
Thank you. So a question for Katrina. Anonymous asks, I think the work that you're doing to build out the community is awesome and awesomely important. As an intermediate Gopher, how can I get involved?
That's a really good question. So there are not very many projects right now that address sort of beginner to intermediate type resources. So, and I think there's room for a huge number of different projects that address it from different perspectives. And so one way is to just start. That's a terrible answer, I'm sorry. On Exorcism, there are a lot of the language tracks themselves. Right now there are 30 different programming languages that we have exercises for, and it's very easy to come in and submit new exercises for individual languages because you don't have to know anything about the rest of the project. Every language has its own repository. So that would be one way of getting involved, is adding new exercises to some of the language tracks on Exorcism.
Thank you. So a question for Rob. With respect to the Go assembler, how are machine-specific instructions like AES handled, or are they largely ignored by the assembler?
They're handled just like the regular instructions. They're certainly not ignored. The OBJ library, in principle, it's an ideal we're still reaching for, contains the bit patterns, effectively, for all of the instructions defined in the architecture and gives them a name. So the AES instructions are given a name and the bit pattern, and once that's in the library, the assembler will find it when it starts up and they will become available. Now, this was not true in the past. That was very spotty before. That may be what the question is about. But nowadays, it should be much better. One of the goals of machine generating the tables from the PDFs from the manufacturer is the guarantee of completeness. This will be all of the instructions that the architecture knows. The problem there, of course, is that you then have to worry about whether the particular chip you're on has that piece of architecture in it or not. In the modern world of variant CPUs, that's a different issue. But the assembler, it just knows what the obj tables know, and those are in principle and one day in fact defined completely by what's in the machine. So they should be there. They're certainly not ignored. In particular, maybe the question is about this. The old assemblers only really worried about what came out of the compiler, is what they were designed for. But nowadays, they're both built on top of this new truth, which is the obj library underneath. And so if the hardware has it, it's available to the programmer through the assembler.
Thank you. So I have a question for Jose. How do you prevent traffic from being fingerprinted by deep packet inspection machines, such as the ones that China is using?
We currently don't do anything special for packets avoid getting fingerprinted. This is a problem we are aware of, and we are looking for ways. Currently, the fingerprints on SSL packets that Go generates are pretty much identifiable. So we don't still have an answer for that, how to do that.
Cool. Thank you. This question is directed to no one in particular. How do you convince programmers from other languages to accept Go's single-letter variable style? Anyone can just jump in.
I think it's really for me, isn't it?
No, it does not have your name against it.
First of all, I object to the characterization that it's Go's single-letter variable style. I think we've been very clear that the way we think about naming things in Go should be appropriate to the use of that name. If you have a two-line for loop, there's really no reason for the index variable to be anything other than one or two letters. If it's a global variable that's used publicly or across many files in the package, it needs to have a much more descriptive name. There's a middle ground of moderation. One thing I will say about Go that we really, really care about, and that I actually wrote about in Effective Go right up front, it's one of the first parts that got written, was to think about the naming as part of the programming process and not just some scribble you put on a variable so you can get it later. Because if you think about the naming from the point of view, especially when you're exporting something to a client package, if the name is part of the public API and it goes along with the name of the package and should be considered in that context as a sort of contract, and the more compact and useful, not compact isn't the right word, but the more precise that terminology is, the easier it's going to be to program in. And part of the criticism of Go about this is that some people misinterpret that for an argument for strict brevity, which is certainly not the case. I think it's more that the Go approach we're taking is a reaction to I won't name any languages because no one wants to hear me criticize Java in public, but there's a tendency to have names that just go on and on and on and say nothing that couldn't be said in many, many fewer characters, and a certain redundancy. For example, the Windows Azure package for Go, which is a great thing to have and I love it, is named like a C# Azure package for Go. And so the package names and the type names all say the same thing over and over again. And it generates a term that I call stutter, where you say, cloud factory package.cloud factory selector. And you don't need to say cloud factory twice. Arguably, you don't even have to say it once. It should be clear from the context what you're talking about. And so I disagree with the thing that we argue for one variable names. We don't. We argue for the right size name for the right problem.
I'd like to add something to that. One of the things that I want to encourage people to do is try things on for size just a little bit. Don't make up your mind before you've tried it that you hate it. Because when you're programming in different languages, the context and the environment make different idioms feel right for the context. And just the unfamiliarity can feel wrong just because it's unfamiliar, and it might not actually feel wrong if you get familiar with it.
I agree completely. And I'd like to add to that sort of more general version of this, which is when you come to write Go code, it's Go code you're writing, not Java code. And so you should be prepared to think about programming in a different way, simply because it's a different language. Not necessarily better or worse, but different. And it has its own community, its own style, and its own usage patterns. And you won't be an effective Go programmer until you appreciate what those are, even if you may, in fact, disagree with some of them.
Thank you. So, Renee, do you have a favorite color in which the Gopher is drawn?
Sorry, could you repeat that?
Do you have a favorite color for the Gopher, like how he should be portrayed?
Yeah, well, I think the blue is the default one, but my favorite plush is for sure the pink one, because he looks like Don Knotts a little bit.
All right, Keith, why does Go use len as opposed to some type.len? Like, why is it a function, not a method?
Oh, why is length a function and not a method on the map? I think that's mostly a historical accident. All the types, built-in types in Go don't have methods. They all have functions that take those objects, and that's sort of just a consistency thing. There's no sort of fundamental reason why you couldn't do that, but that would be Go 1.
We thought about it at the time. You know, we debated it. And the problem was we didn't understand interfaces yet in the early days of Go, and we were worried that if we put methods on the types, that might confound our abilities later or constrain what we could do, which made us a little nervous. And so we just went with functions, which we understood and weren't afraid of. So it was something we thought about, but fairly quickly decided we'd better not put our foot in those waters until we understood the rest of the language better. And by the time we did, it didn't seem to matter very much. Some people really care. Like the Python programmers who come to Go really don't understand why it's, you know, len of stir rather than stir.len. I don't think it matters myself, but, you know, I was there at the beginning, so.
Thank you. So, Bernard, what's a good use case for unikernels? Can you just give us some use cases where Altman would be, like, where you see it being used in the future?
I think the place where I see it, you know, fitting most is as an alternative to where you might be currently using Docker for deployment of a service. You have something that's relatively small, it's self-contained, and you want it to, you know, run it somewhere, and that it's kind of a general purpose kind of alternative to deploying in that kind of way. I think that's the most common way I would expect it.
Okay, thank you. Well, I might follow up with, could we port Go to run on bare x86 rather than inside Xen? Like, what would be the difference there, and what would be involved?
Yes, you can absolutely do this. There's a very early version that's in C that's like halfway sort of there in one of the old trees. For doing it in the current way, you could absolutely do it. The nice thing about Xen is that it handles a lot of early bootstrap things, and it exposes a lot of other kind of low-level components in a nice API. But there's no reason that you couldn't do this also to target bare hardware. You would just have to write a lot more assembly.
Cool. So Katrina, you described a detailed process of code review for programmer challenges. How do you scale this review process as the number of reviewers grows?
I don't. It's terrible. So this is something that I think about a lot. I think there are a number of reasons why people do not do code reviews. I think one of them is that people are afraid of saying things that other people think are stupid or wrong, and being ridiculed or spoken down to, condescended to. I think another one is that they just don't necessarily know how to do a code review. It's not something that all teams do. It's not something that all projects do. And so it turns out there's more to it than just looking at code and saying something. A lot of people will look at code and not have an idea about what is good or bad. They might have a gut feeling and not know how to articulate anything about that gut feeling. And so I think there's a process if we want to scale it, I think that there will be a process of helping people learn how to do code reviews, which is learning how to recognize specific code smells, where in the resources can we point people to when we say that, oh, this is not a good practice, and here is the documentation about why we think this is a problem, et cetera, and sort of train people a little bit in the process of doing a good code review. A lot of people, when people do it badly, it's often either this sucks, do it object-oriented, or good job, and neither of those things are very helpful.
Thank you. So a question for Jose. A common attack is poisoning of the well of an update server. Do Lantern's update servers send signed binaries to the phone? Does the phone have a hard-coded or pinned certificate so that you can verify the updated binaries are legitimate?
Oh, yes. In addition to using pinned certificates to communicate with Lantern servers, we also hold copies of pinned certificates for all the other methods we use. So if we are using Lantern proxies or any other kind of node to get out to the open internet, we are saving a copy that first is embedded into the binary and then is updated pretty often, and that way we can assure that the binary that is downloaded is from a trusted source. And the other method we use to ensure that the binary diff is really computed by the auto update server is a simple signature that was actually in the original source code from Alan Shreve, because we based the client part of the auto updates based on his code.
Cool. Thank you very much. So to Keith, how is resizing a map while iterating through it implemented?
So resizing maps while iterating. There's sort of two answers to that. One is, how do you resize a map while an iterator is currently happening, and how do you start an iterator while a resize is currently happening, and then both. So let's just cover one of those. So if you're currently doing iterations, you're sort of halfway through your set of buckets. So iterating, you're just walking through all the buckets, and in each bucket, you're walking through all the entries. So let's say you're halfway through that, and you decide you want to grow the map. Then you copy it to the bigger set of buckets, but the iterator stays on the old buckets. And so the iterator keeps walking through the old buckets, and now what it has to do is, every time it finds an entry in the old buckets, it has to double check that that entry's still there and it's still the correct value in the new buckets. So basically, iteration becomes not just grab the thing out of the bucket and return it, but grab it out of the bucket, look it up again in the new buckets, and make sure that it's still there and it still has the right value, and then return that. And so that's sort of how that works, and it gets more complicated when you're growing while you're iterating, and when you iterate, you start your iterator while the map is already growing, then where do you start? And there are more complications to it, but that's, the iterators get ugly.
Okay, thank you. Perhaps this is a question for you or Rob, as it probably touches both of your domains. The assembler sounds like the LLVM project. Can you describe the main differences between LLVM and Go's assembler approach? Could be a big question. Could we target Go object as a compiler target, perhaps from other languages?
So I'm not sure exactly what you mean by LLVM versus the assembler. They're two very different things. Perhaps you're talking about some sort of intermediate object code that's then, sort of like a Java bytecode. We could compile Go to bytecode of various flavors. We compile to NACL, basically, which is a bytecode-ish thing. You need to have the right unsafe operations to be able to implement a lot of the Go primitives. And some of those intermediate representations don't have such things because they're trying to be safe. So it sort of depends, and I don't know specifically about the LLVM intermediate code and whether that's available or not.
Okay. The way that I interpret this question probably comes from your slide, Rob, where there's a clear delineation between the different components.
What LLVM, as I understand it, takes whatever program is coming into it and converts it down to an intermediate representation that's common amongst all languages and all machines, and then expands it out again appropriate to the particular machine that you're targeting. And there's a name for that intermediate representation. I don't remember what it is. And that it really isn't what's going on in the Go world. I probably made it sound a little bit like that in the talk because I kept talking about pseudo instructions. But the fact is, the vast majority of instructions that are coming out of the compiler or that you write in the assembler in the Go ecosystem, although they're pseudo instructions in the sense that they're not yet defined as underlying bit patterns that go to the machine, most of them look fundamentally like the instructions of the actual target machine. If you type move W into the assembler, then it really is a move W all the way through, even though it may come out the other end as some other encoding, but it'll probably become a genuine move W. If you looked at the various assembler examples I had for the add function, you could see that the assembler was actually different for every one of them. And that's because those are different architectures. They have different offsets, different sizes, different instructions, different registers, but they kind of look the same. And I think if you look at LLVM and sort of snapshot at the same point in the sequence, or a corresponding point in the sequence, you'd find that they were not just sort of looked vaguely alike, but were almost identical, because they're really compiling to a single underlying virtual machine, which is then turned into the target architecture. That's my understanding. If it's wrong, it's because I don't know LLVM very well. But the common assembly language that I'm referring to is mostly just syntax. It's not a virtual machine in any meaning of the word.
Thank you. So that was the most popular question, which leaves us with the second most popular question, which is to Renee. Does the Gopher have a name?
No, the Gopher does not have a name. It's just the Gopher. That's it. So.
Excellent. 25 likes. There we go. Okay. Katrina, can you offer any advice to helping co-workers learn Go on the job, in parentheses, while remaining productive?
No.
Cool.
I'm just going to bullshit you. Sorry, I'm just going to say...
That's okay, we're all over 18, it's fine.
Yeah, you're all adults. I don't have any good answers. I take a little bit of issue with the while remaining productive bit of the question. I think that's my answer. I want to beg the question. I think that the preparation for becoming productive is equally important to actually producing shippable code. And so I think that it would be important to take a little bit of time and prioritize that process so that you can ship shippable code.
Thank you. Can I say something there?
Of course.
I'd like to point out that every programmer starts out as a beginner. I actually nearly put a slide in my talk. I didn't. I'll say what it says now. I got mail from Ken Thompson one day when I had written the first Go program ever. And the mail said something like, "You are now the most accomplished Go programmer in the world." And the fact is, I mean, that was a joke, and but the fact, it was true, but it was also, I was the only Go programmer in the world. And at the time, I didn't know how to program in Go. I had to figure it out too, and we all do. And sometimes the work of being productive involves sitting there for a long time, feeling like you're not being productive, but in fact, what you're building is not code, but the mental model that helps you become a good coder. And so I agree with Katrina, it's a poorly phrased question. The real answer is deeper.
Thank you. So, Bernard, how do you compare the Altman OS philosophy with the approach of something like Docker? The question goes on, Docker is gaining popularity, but it seems to go in the opposite direction, adding another layer on top.
I think at the moment, like Docker and containers are definitely much farther along. I think the approaches of tools like Altman, it's perhaps an alternate future that we may end up in. I have no idea whether we will or not. I think it will definitely see more adoption over the next couple of years as we figure out exactly when you might choose between the two. And it's hard to say exactly why you might do one or the other.
Okay, thank you. So Jose, how big was the size of the Go library in comparison to your whole APK? Like how much did adding Go to Lantern affect the size of the final APK?
I don't remember correctly. Maybe it was 10 megabytes. It wasn't too big. The size of the whole executable is like 20 megs. So yeah, it was less than 20 megs.
Okay, so what, about 30% of the total, maybe?
Well, we have a lot of media content, of images and things like that. So maybe it's about 20%. Yeah, it doesn't add too much. We could save a lot of space if we didn't use high quality images, for instance.
Okay, thanks. Here's an easy one, Keith. For a map, is there a way for us to predefine the bucket size, length, etc.?
There's no way to predefine the bucket size. You can predefine the length, the number of buckets, and you do that by giving the size hint to the make function for building maps. And so if you want 20 buckets, you allocate 20 times 6.5 or whatever as your length factor.
I guess this is a question for the members who are on the Go team, or anyone who can answer this. I think this probably comes over from yesterday. Possible support for multi-dimensional arrays in Go. Can you tell us more about that? There is a proposal at the moment. Can you tell us more about how that's going and if it's moving towards implementation?
There's certainly been a lot of talk about it. I personally think it's a really important thing to have, but there's a tremendous amount of stuff you've got to get right. And you have to define carefully what you mean when you take a slice of a multidimensional array, how you build a multidimensional array, how the literals work, how the syntax comes out. And there's a bunch of questions that don't have answers that everyone that I've talked to about it is comfortable with. But I can't predict what's going to happen, but I suspect multidimensional arrays will happen at some point. Whether it happens before there's a Go-to, if there is a Go-to, I don't know. I personally want to see them because they make, for instance, two-dimensional arrays make image processing a lot nicer. And the annoyance of having to initialize or even allocate a multidimensional slice, which is really what you're talking about. Multidimensional arrays are already there. A multidimensional slice is really tricky. And programmers who are new to Go sort of are surprised how hard it is. And I think that's unfortunate. And it's addressable. So it's just that we're, as I think everybody knows, treading very, very carefully on adding new features to the language. We really want to make sure when we do it, we get it right because we've promised that we're not going to break anything. And that attitude makes it actually much harder to put things in because you have to make sure that not only that you're not going to break anything that's already there, but that the decisions you make in the design are the ones you're willing to put that same promise on, even though no one's ever used them before. And that's a pretty big bar to clear. So I want to see them in. I personally really want to see them in, but I can't tell you when it would happen. I hope not before too long, but I don't know.
Yeah, let me just add that we've seen a lot of progress on the proposals over time. The initial ones were very sort of kitchen sink sort of proposals. We'd like all these features, and it seemed a daunting task to have to implement such a thing. And we've sort of whittled it down to a smaller set of functions that we think are still complete in the sense that they solve all the major problems with using multidimensional slices. And so there's progress, and we hope we'll get there at some point.
Cool. Thank you. The next question is for Katrina. What can we do to bring more people to exercise.o to provide feedback?
I think there's something that I've observed, and that is that people learn a lot from giving code reviews when they first get started, when they finally get started and have that experience of being challenged to think about their own instincts and express their ideas about good code and clean code. They are forced to think about things at a much deeper level than some of the normal day-to-day just shipping features does. And that's a very valuable experience. And so people who do come to Exorcism and do some code review and have this experience of being challenged, they often come back again and again. And so I think that there is something that we could do to help people do enough code review to start having that experience. And I think that it would grow on its own.
Okay, thank you. So, question for Keith. Anonymous asks, I've often seen recommendations online that if you're working with less than 100 items, it's faster to use a slice and iterate through them rather than a map. Do you agree with this advice? And if so, do you expect it to change in the future?
That advice sounds reasonable to me. I might say that sounds qualitatively right, and maybe quantitatively I would pick a lower number, like 30 or something instead of 100. But yes, if you've got a small number of items, make a slice out of them, iterate through them to find the thing you're looking for. There's no reason to use a map other than before you start optimizing it, make sure that it's actually worth optimizing, that it is a hotspot. Maps are probably easier to use syntactically, and so don't go along changing everything to slices until you know that it's worth optimizing.
Thank you. Jose, how would Lantern's cross-compilation approach be different if you were targeting iOS? Is it possible to target that platform?
It is possible, but we are missing some pieces for iOS. In particular, we need to find out how to do this virtual device thing, because I am sure it's pretty different how to do that in Android and how to do that on iOS. So that's a pretty big one. It's a pretty big one piece that we are missing. But since we are already working with Lantern on Windows and on iOS and Android and on Linux, the client part shouldn't be actually that difficult to build for iOS. But we don't have enough pieces to get a product working yet.
Okay. Renee, the question is the Three Gophers Workshop art image, I think they're talking about the 5th birthday image, available as a laptop sticker?
I think Andrew Durand is the person to talk to about that.
Okay.
Yeah.
Andrew's over there, everyone mob him.
Andrew. Not paying attention?
So, do you want to be the only person in the world with your 5th anniversary laptop sticker, or can other people join in? Okay, so be the change you see.
So anyone can do it, that's the answer?
The inaudible part was he said all he did was grab the artwork from the blog post and send it out to a site that does this. So if you want it, you can do it. He'll tweet the details.
Thanks, Andrew. Okay, Rob, are stack-based processes no longer garnering any interest, or could they be handled by Go's assembler?
We had a Plan 9 compiler for a stack-based machine, and it worked just fine. I don't know, there's probably fans of them out there. I don't think it's a good architecture, and I think they've fallen away because other techniques of microarchitecture have won more than the performance gains that the stack-based architectures were supposed to provide. There's a lot more gates on the data paths when you have a stack machine than when you just have good old-fashioned registers, and I think it's just a performance question that they've sort of fallen out of favor. But certainly, the Spark is arguably a stack machine. Plan 9 ran really well in the Spark. Of course, we threw away the stack windows as soon as we could. The Crisp machine, which was what ran, I think, on the Apple Newton, was Crisp, I think? I don't know why I'm looking at you. I don't know. It was a Crisp, and we had a Plan 9 style compiler and assembler for that machine. It worked just fine. I think some people, from what I saw on the Twitter comments, were sort of amazed that these machines really are the same if you ignore the details, and that's kind of a funny thing to say. But it's true. They're all doing the same thing. They're all just moving data, doing arithmetic. And it doesn't really matter what the underlying architecture is to a first approximation or even a second approximation. So stack machines, sure, we can handle them. Bring one on if you've got one.
Thank you. So I'm going to reword this a little bit, Bernard. But how can a novice developer contribute to Altman? So how would you advise a novice developer to come in and start contributing to Altman?
I don't have a really great answer for that. I've spent a bit of time a while ago going through the project to make it easy to get set up, which I hope it remains true. But I didn't know anything about any of the topics involved in the Altman project before I started. So I read a whole lot of resources, I read a lot of source code, and I wrote a lot of things that didn't work until they did. And that's like the best answer that I have right now. If someone is interested in learning more about these things and wants to do it through the Altman project, I'd love to work with you on that.
So how do you communicate on the project? Is it through GitHub issues, like Gitter, what are the modes of communication for your project?
I am currently the only contributor, but there is a GitHub issue tracker, which I made some notes on for myself.
Okay, cool. So question for Keith. Why was 8 slots per bucket chosen? Is there some magic in this arithmetic that keeps the distribution evenly distributed with 8 slots?
The choice of 8 was mostly a packing issue, that if you want to have your bucket packed well with no wasted space, even if your key is of size 3 bytes and your value is of size 7 bytes, by picking 8, you can put 8 keys together and then 8 values together, and no alignment packing is required no matter what you do. And the pointers are 8 size, and so everything sort of works out when the buckets are size 8. It also sort of corresponds to approximately a cache line size, so that you only take one fault to look at all the data in your bucket. So you don't want a giant bucket, because then you have lots of cache lines to fault in. So it was sort of a sweet spot decision. I think 4 would also be a good number. But yeah, you want something where you can minimize the overhead of mostly the size of things, so that you don't need padding and you don't need too many overflow pointers per entry.
Okay, thank you. I'm going to slightly reword this question. Is there a story behind each year's GopherCon logo? Is there a story behind the image, why you chose the balloon or the cowboy gopher?
No, not really a story. I think the last year's gopher on the horse was just because I thought it would be really funny if there would be a horse with the same proportions as the gopher with tiny little legs, and how physically impossible that would be. Yeah. And how would he sit on the horse, because he doesn't have really, his thigh muscles aren't really very developed. This year, Eric Zelaya came up with the balloon floating over thing, and then we worked together to make it, we just worked on it together.
Cool, thank you very much. Katrina, again, Anonymous asks, how can we help coordinate creation of toy exercises on Excise.io?
We have a repository, so jump in to any of the repositories, I'll see it, and I'll point you to the right place. Right now, the documentation is not in a good place, so there is a contributing doc, but there are 75 repositories, so good luck finding it. If you just jump in and ask the question in an issue in the exorcism organization on GitHub, I will see it and I will respond and help you find the right place.
Cool.
Also, thank you.
Rob, Anonymous asks, do I understand correctly that automatic generation of the assembler from PDF will not include the obj library? That library still needs to be handwritten for new architectures. So I think...
No, you do not understand. Whoever you are, Anonymous. Why can't we know your name? You know mine. No, the point is exactly the opposite, in fact, that the obj library is the thing that gets generated automatically from the PDF definition of the architecture. And that once the obj library is there, the assembler has all the tools it needs to just import the obj library for that architecture and set up the tables, and off it's running. So it's precisely the obj libraries for the architecture that will be machine generated in future. Whoever you are.
Okay. Give me a second here. So, Jose, I think we touched on this before, but maybe you could go over it again. Is Lantern detectable? If so, what's to stop a sensor from blocking Lantern?
Lantern is detectable. Yes, it is. If a sensor wants to stop Lantern, he could do it by inspecting every packet and locating and identifying packets coming from Go, and then a sensor can decide to just cut all Go traffic or to throttle it. But this will also affect other different applications that use Go. So it will be a pretty bold movement. We are expecting that sensors don't decide that yet until we find a solution. And what in an ideal world, Lantern will be able to mimic different kinds of fingerprint from different programs, like for example what Chrome does, the libraries or the libraries from Firefox, or some other SSL library. And this is a pretty complicated topic, but we are aware of it, and we are aware that this is a possibility that sensors can take Lantern down by doing that.
Thank you. Katrina, what are some good resources on using a test-driven development approach? It's not a complete sentence. Using a test-driven approach using exorcism.io. Maybe we'll ask a different question.
I'm not sure I understand the question.
Yeah.
Is it how to learn how to write good tests? Well, I guess you wouldn't know, would you, Dave?
Yeah. So, let's leave that one. Okay, so Keith, Anonymous asks, and I'll have a follow-up, is your favorite package unsafe? But rather than answering that question, maybe you could answer, how do you feel about to implement the map inside the runtime? It is necessary to do all those things which we said Go doesn't support, direct pointer manipulation, addressor arithmetic.
Right, yeah, so I would say Unsafe is probably my favorite package, sure. It's simple, and it's very powerful. I like both those things. Yeah, so what was the second part of the question?
So do you I don't think you love Unsafe. That's cool. Okay, a follow-up. Why does Go lack a built-in set type?
Because it's not a big incremental change over the map type that already exists. A map from type to bool basically gives you a set type, and it's maybe a little bit clunky to use, but is it really that much clunkier to use that we need to introduce a whole new built-in type? That's a tough call, and to this point, we haven't made that call in the direction of adding a separate set type.
Cool. Thank you. And everyone wants to ask that same question about map iteration. Maybe we should go over it one more time. While iterating over the map, and being able to mutate it concurrently, how does this work?
Right, so if you're in the middle of an iteration and you decide to grow the map, then the iterator gets notified of that fact, and that any future items it decides to return from the old buckets, it has to look that item up again in the new buckets because maybe it's been deleted since, or maybe it's been updated since, and so it has to take whatever that new value is in the new map and return that. If anything new thing has been inserted, it will be inserted into the new maps, and the old iterator will never see it. And so that won't be returned, but that's allowed by the spec. Anything that's inserted after the iterator started is not guaranteed to be returned.
Okay. And we're now at 20 past 4, so this is the conclusion of this session. I want to thank all my speakers again. From the far end, Keith Frandell, Bernard Schaefer, Katrina Owen, Renee French, Rob Pike, and Jose Carlos Nito. Thank you very much.